So developing the AI-powered RAN, very topical at the moment, applying AI to the radio access network. Work has been ongoing since when? Goodness me, I do not know for definite. I did a search on my archives. I came up with an IEEE press release from 2019 about this, but I also came across an ebook I stashed away from 2009. So yes, I'm sure our guests here might be able to confirm how long this has all been going on for. It sounds like it's only been worked on for the past 12 months, but obviously it has not. Tools obviously have changed. So how far have we come, which is what we really want to know. How far have we come? What benefits is it providing? What have we learned so far? And more importantly, what is next? And to add some jeopardy to the proceedings, we've only got 60 minutes to find out. So without further ado, as they say, let's meet our panelists. So if I could start on my immediate left with Mark. Mark, could you introduce yourself, please?
Yeah, so hi, I'm Mark Henry. I'm Director of Network Strategy and Spectrum in BT. And AI is definitely embedded in our network strategy. And the way we think about that is, are we just doing introductions or opening comments
just introduce yourself and then we'll do the comments.
I'll stop there.
All right, thanks, Mark, please.
Yeah, I'm Senthil Kumar Dhandapani. My role is Strategy Director in VMware by Broadcom. And I've been in telco space more than 24 years. I'm happy to talk about today AI and RAN.
Thanks, Senthil.
All right. Werner Schaefer with Intel. I lead our global telecommunications sales organization, basically. So you got a sales guy here as well. So maybe different perspective. But sales doesn't know anything. So I got a couple of really people that know what they talked about in the audience as well with me. So it's always good to have your engineer at hand when you're a sales guy. So.
Excellent. We booked one and three come along. Brilliant. That's really good. Good value for money. Thanks, Werner. So, as promised, we've got some presentations. So, opening remarks, really. And Senthil, you're going to speak first. Yeah. So, do you want to walk to the lectern and use the lectern mic for us? If you want to walk over there and give us your thoughts from the lectern, that'd be great. It should be on. It should be on. It should be on.
Okay, maybe a little bit, about myself, I think I talked about actually. So, we in the VMware actually, so we provide a telco cloud platform and that empowers, many of the operators' networks. And specifically talking about AI, we are working with wide variety of operators, and doing a trial at this point in time. And a lot of learning coming across on this one. And if you take an example, like, starting with how to learn from, let's say, like from the algorithm and going into the inference and making up some of the, the learnings, what we got over the period of time, it's really amazing. And I do believe in the coming years, it's going to change the landscape of what we are going to see in the telco, specifically with, I would call it as legacy AI, because we have Gen AI on the other side. So people talk this, the AI as a legacy one, and then Gen AI is coming as next that we are going to, delve into. So that's really, what I really want to share today as a quick one. And I would like to really have as much as interaction and then take a lot of questions from you and then share my experience, what I gained over the period of time, specifically about RAN as well in the AI space.
So, Joel, thank you very much indeed. Thank you. Mark, do you want to follow up?
Yeah, sure. Answer your question about when I first came across the use of AI and RAN. Before the BT acquisition, I worked on I was involved in a project with one of our parent companies where we were looking at devices in the mobile network, measuring their channel state conditions and making a prediction. So this would have been 2017. And it was kind of magical because just by measuring the radio predictions and then building a model on top of it, you can predict the device is going to hand over with really high accuracy. You know it's moving because of the changing conditions, but you can do it in time. And that was an indicator of the kind of things that we could do. Has it been done in a real world? I don't think so, yeah. Unless it's inside one of those black boxes that we buy from the vendors. So overall, what do we think about AI and networks in BT? I think there's sort of three phases to a transformation when we talk about it, but there's one enabler that we really need, and I think you mentioned it earlier. Is, start with the data. So we need a network data layer, and we need to wrangle that data into a format we can use it. Now, our cloud native network applications, they will provide some of this data. The unstructured data, the structured data, we need more of it, and we need to, as I say, get it in the right format, make it usable. And, my understanding is in almost every single AI project, that's where you start. You can't get anything done until you've figured out what you have in the data and how to use it. So, but also network data layer as a concept has been around for years. I co-signed a white paper on it in 2018. But there are steps on the path that we have taken in terms of deploying a network cloud, in terms of getting those applications into software, network functions into software. And then, so with that enabler, then you'll start to see, and we're doing this in pockets, lots of things in different areas, but this transformation is we start off with automating, but with a human in the loop. So we get a prediction for next best action, as an example, and then an engineer, in an operations case, will decide to take the recommended action. Then we go more closed loop, hands off, and we're just checking that the automated process is running. And then the sort of third phase is full autonomy, where these closed loops are running, but they're also interacting with each other. And then you're abstracted, and you're making sure that the service you want to be delivered is running. And then there are just loads of opportunities to apply this in different domains. So computer vision is great for doing inventory, something we've done already. Engineers take a picture of a cabinet and we just get inventory from the photo. So we're doing some things there. Then resource allocation, including network resources, but also all of our engineers. We've done quite a bit of work to optimize field force scheduling, which is a classic problem, the traveling salesman problem. And then things like pure optimization. So the RAN, we do a lot of parameterization, and you can use machine learning really to optimize that parameterization for the goal you want. But I think we'll come on to some of this in the question. One final thing I'll say is we don't think, and it's uncertain, but we don't think that you'll see a massive improvement in signal processing. The throughputs in networks are, constellation diagrams in spectrum, in light, in fiber are fairly mathematically controlled. So unlike protein structures, like DeepMind characterized protein structures, and we went from 100,000 proteins to 2 million well-characterized protein structures. You won't see that kind of step change in throughput in networks because it's, fairly controlled maths. It requires less prediction. So we think less opportunity to just in software double the throughput in our networks, but still loads of opportunity for optimization. Hopefully that wasn't longer than 5 minutes.
Perfect, Mark. That was really informative. Thank you very much indeed.
No
Werner, please, let's work your way along the back of the stage. It's a bit tight.
Well, so obviously from a Intel perspective, we're looking at this primarily from the infrastructure side of things, obviously, and then looking at AI. And to Guy's question about when would you start thinking about it, right? If we go back to our NRV days, which all is a while, a lot less gray in that beard in the NRV days, we saw that as something down the line, right? So virtualization, cloudification, then what we get with that. But as a company, as someone that has a company that has had that vision all along around how do we get that, how do we make data more really the gold mine for our customers, right? We're super excited, obviously, about AI. And, we get a lot of question about, well, there's this other company that everybody talks about right now, right? And if you happen to be, unfortunately, on an H100 waitlist, well, good luck. Maybe in 25, you're going to get something. From our view, that's obviously all wonderful because today 90+% of inference is run on x86 Intel, and that will stay for a while. And we're also obviously working on the training and those products. And then someone has to build all that wonderful infrastructure. And as you know, we're investing heavily in Foundry. So yes, everybody buy as much AI infrastructure as you can. We're happy to do that. Don't forget to buy some Intel stock on the way. And you will hear a lot more about that next Thursday when our CEO is actually going to do an AI and everything presentation in New York. It's open for everybody to dial in. And that was my shameless plug for Intel, I promise. As I said, we've been around this from the VNF days, from the NFV days, and looking at this from the RAN as well and saying, what we're doing there in the core, it's got to go and move all the way to the RAN. So doing that now is obviously giving the basis for really putting AI into that. Because as you are software defined, now you can really plug in your software tools and you can do all these wonderful things. Who would have thought? Announcement on Monday from Ericsson and AT&T. Would you have thought about that 2 weeks ago that Ericsson would come out and put that plug in for O-RAN? If you have thought about it, you had some prior knowledge. I bet you. We had some of that. That's why we are in that announcement as well. And we're super excited about that because we really believe that that's going to be the accelerator that we need. That one of those big temps is going to come out and say, yes, we are fully committed to that. And we're going to do that. We'll see how that's going to shape out for the other temps, if they're going to follow up on that or what's their path going to be there. And I think that is also what will, in the debate that we hear today, do a lot for us in how that's going to be driven. How much are they going to be building in those AI, the APIs for that? How much will they actually help us to really harvest what comes out from the possibilities that AI is going to bring? And we're super excited about that in working with operators, with the equipment providers, and with service providers around that, and all those new AI companies that are going to come out there and figure out how we can do that. And you may or may not know that Intel actually employs more software engineers than VMware has. So we're a bit in the game there and doing more than just the silicon. We obviously want to put this all around and bring the software and bring the solutions in place there as well with our partners. And we get a lot of input from the operators to do that. So excited to be here, and we'll see what we get the debate.
Great. Thanks very much. Well, thank you to all of our guests for those opening comments and setting the scene. Now, I've got a number of questions here to ask, but because we've heard from our three guests, why don't we open it to the floor? If anyone's got any immediate thoughts or comments from what they've just heard from our guests, I can't see any hands up in the air whatsoever. It's in your hands in the air. I'll continue in a sec. 1, 2, 3, 4. Oh, crikey. Come on. Yes. More hands. All right. James, come on.
Thank you so much. Mark, you mentioned that sometimes this AI is embedded in the... James Crawshaw from Omdia. Mark, you said that often these AI capabilities are baked into the boxes, the black boxes that you buy from suppliers. As you try to do your own AI projects, do you still encounter the difficulties getting the data from networking systems and network suppliers saying, no, you can't get hold of that data. That's our data. Is that a problem still?
I wouldn't say it's a big problem today in that we've got loads of data that we're not taking benefit from. But I think longer term, we want to be sure that we can get exactly what we need out of it, and make sure that's in an open way, so that we have control of the platform and use it for what we want to use it. Applying to the RAN what we've done in the core, basically, with our network cloud.
Thanks, Mark. There's Dean and there's Neil. So I'm going to Dean first. Dean.
Thanks, Dean Bobley from Disruptive Analysis, and this is a question to the panel, but I know particularly Mark. What differences are you seeing between AI applied to the RAN versus to the fixed access network? Because I noticed you mentioned things like field force optimization and taking photos of cabinets, and both of those are very fixed oriented, whereas obviously the RAN parameterization isn't. So are you seeing convergence or divergence of fixed and mobile in terms of AI?
There's a lot of commonality. Clearly, field force is the same. In terms of optimizing the RAN, the complexity is much higher. Just in terms of the radio resources, doing handovers, the parameter set you have is different, and there's just additional complexity because devices move around. It's a fundamental. So I'd say that's the main divergence, but fundamental layer, there's a lot of similarities. So I think we can take learnings, and we are. The inventory stuff we're taking directly from what we've learned on cabinets and applying it to sites. We need a camera that flies, but same principle.
Thanks, Mark. We do want to get some comments, Senthil?
So if I may add, actually, so as Mark was saying, yes, actually, some of the algorithms can really use what we can, both worlds like fixed networks and RAN. But having said that, as Mark was saying, in the RAN, for example, you have the channel and beam, so a lot of the information you need to collect, process. So the complexity in the RAN is much higher compared to fixed networks. But I think we will see many of the, let's say, algorithms will be used across the fields. Actually, that's what going to happen in the in the coming years.
Yeah, I think it's an algorithm question. There will be some applicable to both areas, and there's some that will be dedicated to one or the other. Right. So if you think about power management, power utilization, down use, that's probably one. Okay. Yeah. No, I think I said it's a question of there are going to be some algorithm playing on both sides, and others that are going to be dedicated. So.
Okay, thanks very much. Neil's going to come across to you first, and then I'll come up to the top. But Neil.
Hey, yeah, I'm Neil McCrea. My question is value and return. So AI, big power, big data centers, and if you are running a network reasonably well, it's probably not going to help you as much as you think. So how are you measuring the cost of bringing AI to the radio versus the benefit that you're going to get?
Who'd like to take this on cost versus benefits?
Well, it's
Mark, you can step out of this.
Sorry to go back to the reality.
So full disclosure, I used to work for Neil, so he knows the questions to ask. How I imagine it? Well, a lot of the things we're doing right now don't require us to build additional infrastructure. So it's kind of low cost, maximum benefit, particularly in energy, for example. But if we were to, let's say, we're starting to develop a business case for centralized RAN, cloudified RAN. If we were to put some benefits in that we would gain through the application of AI and machine learning from that platform, we're going to have to do a really good job on characterizing the cost benefit analysis in that. We haven't done it yet.
And RAN's kind of, what's good in Exeter is a bit different to what's good in Docklands. And I kind of wonder, what's your thinking around how do you engineer a control plane so that the benefits that you might be able to get are actually deployed into the network?
So I think we today we optimize on clusters, which are specific to the traffic patterns that you see in a cluster, and we'll make that much more dynamic. And we're seeing solutions from the vendors for this as well, where we go, typically we'll deploy parameters overnight, and we'll get to an RAP that is near real time, so it will be able to change parameters within the sort of 1 second time domain. And that is a pretty decent proposal for how you would do it. And there's people lining up to sell us our apps that will do it. We would also like the ability to do it ourselves, because every network is different, and it is different in Exeter than it is in Docklands. And we want to tune very much for our own traffic patterns, our own customers. So I think that's the kind of proposed architecture. But yeah, we haven't built it. We haven't, settled on it yet.
Yeah. So maybe if I may add, actually, so from VMware perspective, at least we use the methodology called software-defined developer kit, SDK kit, which we open to the ecosystem so that they can come and develop their own XApps and RApps actually. So then that can fuel the innovation in the RAN actually. So I would say that that's a way probably to look at where the area we want to really start actually. So and then talking about RAN specifically, to me, like the scheduler, like probably it's one of the area where you could use the AI and make it more robust. And then moving on to the non-real-time rig area where you could also tap the benefits of the non-control plane related the parameters and settings actually. So this is the way I see, start with the kind of the near real time and then move on to the non-real time area, and how that's how you reap the benefits actually immediately with the AI.
Yeah, Neil, I would say from an infrastructure perspective, there's only two ways that you can argue, right? Either you save cost or you make more money. Otherwise, your CFO is not going to be really happy to write that check for you to do the project, right? And when we talk about the RAN, it's probably more the cost savings right now than necessarily saying I make more revenue out of my RAN. Potentially, I would say, Mark, it's where your emphasis is, right? So that gives you the thought about, well, where's the TCO going to be? What can I do? And that's pretty simple as what's your biggest pain point in the RAN right now, right? What are you looking for? And one thing that we're hearing from every operator around the world right now is power management, right? If you look at, the cost, and I'm pretty sure it's not any different for BT from anybody else, it's like way, way up there, right? For some of them, it's even before people cost, it's their power consumption that they have. So how do we help with AI optimize something like that? That could give you probably a fairly quick view of how applying AI to my RAN will be helpful there or not. I'm not saying it is, but that would be how I would go about making the case for an investment there.
Great. Thanks, everyone. And I think there was a question? There we go.
Hi, Justin Paul. I hate to be the doomsayer, but what are the risks of an AI-powered RAN? And when it goes wrong, how are you going to mitigate those risks? And if you have an AI-powered RAN network and it falls over, what do you going to have to do differently to get it back up and working in terms of unplugging the AI from that system?
Yeah, maybe I can take this question because it's like it's I think it's down to the algorithmic bias what you're alluding to actually. I would say that it's typically what we do even in today network. Like you need to do a periodic audit and making sure that you have the the closed loop mechanism in place. So it's going to apply same thing for even when we move into the AI world, and specifically talking about the algorithms which we use for landing and then going further down into the the inference. So I think that's given actually, and then this is coupled also with the regulatory what we are talking about heavily, like even in the other field, especially in the telecom space. Actually, it's going to play a lot of the role here, and I would think that. The security again. So I think we are talking about a lot of things, regulatory, security, and so on and so forth. But I don't see no difference than what we have in the telco space already, actually. But it's going to be more robust with AI coming into play, and that's what we are going to see.
Yeah, I'm less of a doomsayer. I think AI is probably an unhelpful term in that regard, though, because it's so broad. But the journey I talked about that we go through. We deliver carrier grade services. We've got to connect 999 calls, so we won't take many risks. And we'll learn as we go and very carefully. Things we would worry about, things like runaway processes. When you go hands off, and you can get into a failure state, which maybe it just keeps breaking it and fixing it. and it's just flip-flopping the whole time. But that's just an abstraction from today. We have engineers that monitor alarms on network devices. Tomorrow, they're monitoring that process and they see that it's got into a failure state, or they're alerted and we take an action. So each time it's some abstraction, but we will always be humans monitoring the process that's in play. And then in terms of coming back from a failure state, we always have the ability to roll back to the stable platform we had before. We always have the previous software version ready to go, or fixes that we deploy in test in the lab that go straight into live. We do that all the time.
Great. Werner, anything to add?
I think the regulatory part is the most important part around that. And that will be both self-regulation from a company perspective, as well as it is from the regulators in the different countries and what they are willing to actually accept there, right? Because telco is still one of the most heavily regulated industries in any country in the world. And just as we have 911, 999 here, it's 911 in the US, right? And if your 911 service is not supported, it's an automatic SEC notification, right? It has super impact for the operators. So they will have to have those fallback mechanisms in place. There's no doubt about it. But it's contra a little bit to Guy, when you were saying, well, how fast, right? Well, we're going to be fast with the product being out there. This is probably an area around where we don't want to be quite as fast, and maybe try it out in certain areas first to see how it works before we roll it out across bigger parts.
Great. Thanks, everyone. Question at the back.
Peter Baycroft from AMD. A question for Mark. You've touched on a few areas of potential value for AI. One of them being operations, so I guess needing less people, running a better service, network reliability. There's value there. You've touched on sort of network planning and squeezing the most out of the network you have, and also understanding the customers that you have and potentially generating new services and generating revenue. In terms of priorities, where do you see BT going first, right? What is or do you see any other areas where there's significant value?
Yeah, energy is number one. We've done quite a bit of work on that. Anne, who's in the room here with us, has done quite a bit of work on that across the teams in BT. So that is a clear priority. I was told recently that BT uses 0.7% of the national grid power at peak, and the fluctuation in cost. So, networks for a long time have patted themselves on the back for saving energy in other areas, but that's not sufficient. So that's priority number one. Then it's performance, and performance, comes with efficiency as well. So cost, absolutely, whilst maintaining the performance, and there's a trade-off, and I think we'll come on to that. And then a bit on improving the service as an opportunity. And probably today, you buy data from an operator, it's all best effort data primarily. The voice service on your phone is prioritized, and we do some quality of service, obviously, for some of our customers, like the emergency services network that we're building. But once we get to more quality of service in the network, and I know there's some difference of opinions about this, but if you look at what's coming, where devices will start signaling traffic types towards the network, so this is called URSP. It's available on the Apple developer site today. It's embedded in iOS. It's embedded in Android. We'll be able to identify traffic types and then provide a quality of service. Once we've got several of these different cause profiles, partitions in the network, which are dynamic, this is all really talking about the RAN. Nobody's going to be able to manage that without maybe a very large team and a massive coordination problem. So I think that is an opportunity for managing and optimizing that, is one that's probably in the enablement of new services is on the list.
Great, thanks. Tell you what, new face. Francis.
Francis Hayes from Apple Law Research. Mark, you mentioned the doing stuff in 2017.
Senthil? No,
That's
fine. Go on,
they're going to be
Francis,
involved
fine.
as well. You really expressing you could have done something in 2017, yet we're here in 2023 and you haven't done it. How much do you think this is probably the most standards-based area of the network, RAN, and how much do you see standards as being an enabler of the use of AI, and how much do you see it as being a disabler, or the way in which data is hidden and things like that? And what is the danger that you tackle what I would term is the peripheral issues of the RAN, what the operational issues of the RAN, rather than how the RAN is managed? And VMware, for example, a lot of work on RICs and that kind of thing, which is much more fundamental about changing the nature of how the RAN itself runs itself. So rather than is standards an impediment to us actually really using AI well in the network, or is it an enabler?
I don't really see them as that related. In that standards will standardize interfaces between functions, and you can get some data that is standardized through that, but you'll get more from whatever vendor is providing it. But that's just the control and user plane interfaces for how a network is operating. We have a whole bunch of management interfaces that control a network, give us loads more data. And we can pull loads of data directly off the devices in the network when they report their radio conditions. So we get masses of information that's outside of standardized interfaces through management information systems. And that is quite sufficient for what we want to do now. Now, if you talk about a scheduler, we don't, we buy Ericsson and Nokia radios, and the baseband runs a scheduler, and we don't see how that works. Now, I'm aware of one operator in the world that writes their own scheduler and gets the vendors to implement it. And that's a debate about whether, who's best to do it, who's got the experience and scale and has done more work on it. We don't have a team that would go and write a scheduler tomorrow. So, I don't think we're in that game. Over time, we may get to a position where we want to understand, influence scheduler, but I don't see our vendors going, no, you can't do that. When there's a benefit to be had, then there's a discussion to be had. Now, whether there's a problem with vendor lock-in and things like that, I think is a separate discussion. But largely, I'm not worried about standards solving or enabling for AI.
Thanks, Mark. Well, let's hand it across and Senthil.
Yeah, so my thinking is on the standard perspective. For example, if you look at 3GPP, so they are planning to define a specific only on release 18, and specifically beam state and channel state, and then all the positioning, etc., which is quite late in a way, when it comes into kind of implementation phase. So and then you look at, we do have multiple standards, obviously, for telco's perspective. So that's one thing probably the whole industry need to think about, on how we need to expedite the standardization, especially if you're thinking about developing a common AI algorithm and moving fast in this field, unlike what we do in earlier, in the traditional way.
Do you think we need a common AI algorithm though?
Yeah, that's a good question. So I would say that from practical aspects, it's not going to be really viable at this point in time, having a one common AI algorithm, even though we strive to reach that state actually. So that's purely because there are challenges with technical, regulatory, and then also sometime, as I alluded earlier, for example, the algorithmic bias. So a lot of things needs to be really addressed on that one in order to realize the common AI algorithm. But having said that, we already moved into for example, the Open RAN, where we disaggregated everything like CU, DU, and so on. And then also seeing a real value coming out of that, like, for example, like, the scheduler, like, how we can make a lightweight and then move into for example, the near real-time rate, which is where, kind of VMware perspective, like we are heavily involved and then, trying to work with, across the vendors to develop kind of the XApps, which we can, really, fuel the innovation. So now, in summary, I think the standard, first of all, they need to, really evolve. That's clear. Yeah.
But I just wanted to pick up on what you just said, because this refers to a note I've got here about whether or not is it possible to govern the RAN with a single AI algorithm? We've had a discussion there, and Werner, I'd love to get your thoughts on this as well, because if it's sounding like that's not something we can do today, is this still a long-term objective? Is this a goal, or is it no? We do need multiple ones, and if we use multiple ones, what's the risks attached to that?
Well, I think time will tell. I don't think it's something we can answer necessarily today. We've got to start with defining them for the different use cases that we had before, and then see if we can get to one. And I think that's actually where standards are going to be the key to get there, because standard leads to competition. Competition leads to innovation. If you don't have the standard, you don't have a vendor choice, right? So to your lock-in question before, and I think that will also then define of how many algorithms, how do they interact? Will we have conflict in between different algorithms trying to accomplish different outcomes? But all that will probably come out of a learning experience and a standard question. I don't think it's an impediment. I think standard actually help us move along that line of choice and of innovation.
Great. Any points about the single algorithm while we're here? Well, yeah, David, I'll come to you first because you caught my eye first.
Is it the haircut? No, it's just when I hear the word standards, I think I'll just stick my hand up. We in ETSI 3 GPP, we're doing AI standardization all over the place, different areas, different technologies, but it mustn't be placed at a time where it stops innovation. So AI is a massive development curve, lots of things coming out of the labs, lots of things coming out of programmers. That's fantastic. Let that be creative. We're seeing what's happening with ChatGPT and other things. But at a certain point, when it goes to carrier grade, you need some reassurances that AI won't run away with the network. Different shapes and flavors of AI won't interact with each other. If you're doing AI for sustainability, which goes against AI for performance, how will that work? It becomes interesting when it's the AIs talking to AIs, the human in the loop control as well. So let the innovation happen. It's happening now, but you need a certain amount, just the right amount of standardization at the right time to enable the innovation to continue into carrier grade. But we'll talk about it later on.
Okay. Dean.
Hi, Dean Bubbly again. Yeah, no, it was. I was going to follow on that and thinking, presumably standardization, either of the algorithm or the data formats must be necessary when you want to do optimization across boundaries. For example, between an operator and a tower company, or an operator and an MVNO, or two operators. Yeah, how do you manage? Does that require standardization at the boundary, presumably?
I would think yes, because for example, if you have a data set, I would think yes, because for example, today, if you're thinking about the data set, actually, most of the operators are precious about the data, so that's kind of the given. But as we step into the AI world, one of the things probably we need to think about differently is to have a common data set, and then develop an algorithm which can be done in a very quick and robust way that can be again used by the many of the operators, and we don't need to wait doing let's say every vendor or the operator wise, actually, that's not going to really work actually. So definitely there is a different thinking is needed here.
Great. I think you've been gazumped.
Oh, have I?
There we go.
So on standards, I think just to add something, I think, so there's this research into an AI-based air interface for 6G, where if you have a much more dynamic, scalable air interface that hopefully is backwards compatible and potentially forwards compatible, then you would need to standardize, absolutely. right? Because standards is helping us have an ecosystem, a global ecosystem, right? Which gives us scale, economies of scale that we can deliver these things at low cost and deliver those benefits. But a lot of the things we want to do, the opportunities that I laid out. For example, to optimize coverage, you change the tilts on your antennas. Most of our network has this remote electrical tilt. And we look at the traffic patterns and we optimize the coverage, make sure we're getting the loading right. It's all, done on a monthly basis, kind of. And sometimes longer than that if we don't, there's no problems been seen and we're not really optimizing. That could be taken into a dynamic environment pretty easily. We've got all the components. We haven't built a machine learning model to do it for us, and we haven't tested it yet. We don't need any standards for that. And it could give huge benefit because as the traffic moves around, you can then start changing the coverage. And then we see similar things outside of standards again. So we have a whole bunch of Ericsson radios that we just using to swap Huawei out from our network. And MWC, they announced an improved interference cancellation algorithm for massive MIMO radios, 40% spectrum efficiency improvement. No standards required. 40% spectrum efficiency improvement is huge, absolutely huge. So I don't want to wait for release 18. So we need to coordinate where we need to coordinate, but outside of that, we're just going to do stuff.
Right. Thanks, Ivan.
We have
Raj over there.
Raj Javatkar, Juniper Networks. So I want to make 3 points, and one of them is directed at Mark. That I don't think we need a common AI algorithm. We need a common data model. The point somebody made about crossing the operator boundary or the tower versus operator, what you need is a common data model. And then the algorithms can come and go based on what you're trying to achieve, what kind of environment you have. The second thing I wanted to talk about was scheduling, right? Scheduler can operate at multiple levels because there's a near real-time scheduler. And the traditional vendors do not want that. They want to continue to own the scheduler. So it's up to people like Mark to decide where they want to put the scheduler. But also non-real-time rig can have a scheduler. I mean, we have done that at Juniper where we are deployed now commercially, where we have XApp and RApps that take advantage of that. And that has to go with admission control at both cell level across multiple cells. And the third thing I wanted to ask, this is really for the Mark, the question is to be able to apply AI, right? Ultimately, the operators have to step up more because you have lots of data. The data is not shared for multiple reasons, regulatory reasons, but there has to be a way in which you can start taking advantage of vendors like us who are developing AI algorithms as well as public cloud infrastructure, because there's a lot of stuff in Databricks and others have, which can be used to use library of machine learning models that can be applied for optimization.
Yeah, I think it's a really good point. We do need to do more and move faster. One of the things we can't do, though, is just buy 10 AI experts and say, make my network better. And it was the same with cloud in that we apply cloud technologies to domains, and we have to teach the domain experts who know how the service runs and how the service is delivered, how to use these new technologies. So in BT, like when I talk about it, I talk about democratizing AI tools within BT. This is a longer process of change in an organization. And what we see when we read all these news articles is kind of tip of the iceberg of these organizations like OpenAI, where they've been working on it a long time. There's 20 PhDs who spent their entire life for 4 years preparing for it, and we're just not there yet. So, on cloud technologies, this concept of the experience curve. Anyway, we're on the steepest part of the experience curve today, where we're migrating millions of customers to this new platform, We just want it as stable as possible. So we're not gaining the benefit. And similarly, we're probably at the top of the experience curve on AI. We're starting to do things, and we've got some really smart people who from research who've worked on this for a long time, and we're trying to leverage that and scale. But it will take operators.
But do you have to do it alone? The question is, do you have to do it alone? Because you have, if you build an open ecosystem of vendors, XApp, RApp developers, they will come with expertise and they will do machine learning algorithms and build the models.
Yeah.
You own the data, you own the data model.
And we're definitely open to partnering and going with best of breed. We're not a do everything ourselves shop for absolutely. Where we do though, we need to maintain a core competency of how we run and operate networks. So absolutely, we're always going to have that. But yeah, we will always partner and buy the best solution. We will not compete with our vendors on the things that they're best at. Absolutely.
Thanks, Matt. I'd like to bring in Senthil and Werner, especially on the thought of all the comments about the need for a common data model and your thoughts on that. And then I want to go across to my colleague Ray.
Sure. So I think even Raj raised that question actually, which I also commented earlier. So yes, so today, we don't have a common data set or the data modeling available. But the way probably, without spoiling in the next coming up the panels, I would think with the Gen AI coming into picture with large language models, this could be, probably addressed in a way like, where we can have, for example, at least the training data set could be generated by LLM itself, that can alleviate this problem a little bit actually. So I think probably, there are two things needs to happen. One thing is very clear, like every operator or the forum needs to come forward. And along with the standardization, what kind of the data set can be generalized, which can again bring the benefits to everyone, correct? And again, we need to respect all the regulatory GDPR, for example, in Europe. So within that boundary, there is something needs to happen. Second, like I do believe with the Gen AI coming into the force, actually, there is a way to really, address this problem actually. So, but time will tell. And then also I'm looking forward to the next panel, how they think and what their thoughts on this one.
Great, thanks, Senthil. Werner? Your microphone's off again.
There is the need for that model, definitely, but there's also a question of what are the different data sets look like, and they will be probably very different for the operators around the world, and even in a country. I'm pretty sure there's different data sets and applicability to that. Just in the BT network in a fairly defined geography like the UK. Now I know BT is doing more than that, but using that as an example versus another country of other topography, other population. So time will tell.
Great. And Ray, you want to come in?
Yeah. So following on from that, I wonder if the focus of the industry maybe right now is a little bit too far ahead of itself. Does the vendor community need to be focusing right now on helping the operators like BT to extract the correct data in a standardized way so that people like Mark have all of the right data they need in a very simple fashion, and then to be able to use the AI tools from there? Because it seems to me that all of the operators I talk to, they're still doing all of this data extraction and trying to find the right data and then use the data all in a completely different way. So rather than be, developing the X apps and R apps now and talking about, Gen AI model for telcos, should the vendor focus be on helping the telcos to get the best and right data out of their networks and their systems to get that starting point? Because they clearly still need help.
I would say if we want to make money, that's what we need to do. Because if I have a future view and say in 5 years you can do all of these things, back to make Ray's point there, I'm not going to get the money from a CFP to invest in anything if I don't show the return, and the return will be exactly what you described right now. How do they get the quick return? How do the operators get the data that they need?
Any vendors working on this, then?
I would think probably this is like probably Neil has some point, but before that, just a quick one. Probably, having the open interface, like for take an example in the Open RAN, we have the E2 interface A1, which I believe that's a 2 key interface. And by, having the standardized interface and then the way of collecting the information and bringing and making the standards of the data sets, that's it's going to, probably address that the requirement actually. That's what I believe.
Yeah. Sorry, we've been talking about algorithms and models kind of interchangeably, and I think we're missing something really important, which is that the models that we use will be constantly changing and updating. In other industries at IBM, we are seeing updates of models almost every day. And so we should not think of this as something that's static and you publish it and it's done. Hence, I avoid the word algorithm because it kind of implies that static. And we should be using the word model, which is a dynamic model that changes. I'll give you an example, right? My rental car I hired last week, as I was driving around town, it misinterpreted 30 miles an hour for 80 miles an hour. Why? Because yeah, exactly. Because
It's what you told the cop that pulled you over,
that's
right?
right. Yeah. Because it misinterpreted the sign, because there was no feedback loop that suggested whenever it told me to drive at 80 miles an hour, I drove at 30 miles an hour. Right. So that's what's kind of broken in the current generation of AI that we see literally on the streets today. That will change with LLMs and how we use data to reinforce the models with real life events.
I think with probably even, as you said, like before even stepping into Gen AI, I think today with even like as you're saying, that deep reinforcement learning. So we have the DRL. So I think it's a matter of fact, like how do we combine the different things like, supervised, unsupervised, and then reinforcement learning. And then along with the closed loop, I think that's one of the key point actually, because it's not going to help only you pick and choose and combination of these algorithms, but there needs to be a closed loop, which is very mandatory thing for the telco, right? So where you need to continuously learn and then implement. Actually, it's not going to be one time develop and then go and implement.
I think it's a really good point actually, because we should worry about model drift because it's taking feedback in real time from the data as it's generated, if you have this closed loop model. So part of that monitoring and assurance of the process, and in the end, it all has to be tied to the service that you're delivering. So you have to monitor for model drift. And I think this speaks to your point, David, about models interacting as well, because they may cause each other to behave in different ways, just unforeseen. I mean, we should worry about that. And on those different models, because I think it was like the original question, you're spot on. If we optimize purely for energy, performance will go down. And we do spend quite a bit of time thinking about how we can make our network look like the best for when it's benchmarked. So we have this competing, we want the network to be very efficient from an energy point of view. We want it really high performance at any point in time. And then, a third one would be reliability. Because if you there's a scheduler choice, in fact, and we see differences between vendors. If you focus on reliability, peak throughput will be down because it's effectively just giving resources to more cell edge users. So if we just had those three algorithms and let them run, I just see chaos because they're fighting with each other. So tying those models to the service that we're delivering and the demand is very important. And I don't know how we do that. I don't see it as a single algorithm where engineer just says make network better. But I think it's important this coupling and monitoring of model drift, and again always tying it back to the service, and then we will just have to make some difficult choices on what we prioritize in the end because there's a fixed set of resources.
Yeah, I want to go back to what Ray said about, who's helping the operators there. I think the ecosystem is coming together and is doing that. There is, bilateral, multilateral conversations going on with the equipment providers, with others around. How do we actually enable that, right? What compute is needed? What infrastructure is needed to allow these AI applications actually to run, and where are they run? How have they been run? In our little pre-panel, we talked about, do you need extra accelerators? Can it be done with your standard compute? Right? Those are all conversations that are already very deeply happening. We have them for sure.
Great. Thanks very much.
Just wanted to bring
pressing. So
two very brief points. Can I just remind everybody that the biggest cause of network outages is it's not AI, it's humans. So when we're worried about AI in a world where we've just had two really big network outages lasting hours that were, one, the CEO got fired. I want to really reiterate the point. If anyone believes that today's networks will advance beyond us just sending YouTubes to iPhones, AI is just not an option. Automation is just not an option. What
do you mean not optional?
Yeah, sorry. We must have them. The fact that we've manually got as far as we've got is a miracle in some respects, but also shows the expertise that we have in our industry, right? I think you look at London as an example. Most of the base stations are still aligned to London of 25 years ago when we set out GSM. So we can't run the network like that anymore if we're really going to drive more value. And then the second point to that is and it's kind of weird having gone from the telco side into working for a vendor. Let me tell you, telcos have got all the data they need. They don't need any more data. In fact, they got data coming out of ears and locations and pipes that they just don't know what to do with. What we need is a way of them exposing that to the wider community in a safe way that they feel adds value. And right now, none of us in the vendor world have made a great case for that. And it's something that working at Juniper, I've been trying to figure out, how do we expose that data? And I'm not talking about from servers or radios. Yes, that data is important. I'm talking about a guy walking down the street with his phone and annoyed that he's had 3 call drops on Teams. That's the data that's valuable. And it's very hard to share that data, but there's no shortage of data. Standards are helpful, but actually if you've got a decent coder, he'll work around any data issues. So that, I just think we should bear that in mind. And one of the things we've been trying to encourage at Juniper is experimentation. So we're setting up labs so that people can experiment with this in a safe way. But when I was building networks, we could turn a network off for a day and no one noticed it. But today, people notice it. So we've got to figure out that path of experimentation, and think like a Formula One team. You got concept in December, museum the following December. We need to be thinking about that as our way of building stuff much more than still trying to support technology that was around when the original Mac was launched.
Thanks, Neil. Any quick thoughts and comments on what Neil had to say there before we wrap this up?
Sorry, I was just going first. Really, really good point, I think. And sovereignty and TSA are playing against that, so we need to find a way through it. But I agree. Sorry.
Yeah, sure. So I think the interesting point what Neil made actually, so at least from VMware perspective, we made one further step, like we created a RIG partner program. So where so far, we have 25 vendors onboarded, and that really, helps and accelerating actually. So yes, we do need a lot of initiative like that, but I think again, so that's the way to go.
Thanks. I think, Neil, with the question of sharing the data, if I'd be an operator, I would be thinking about how I actually monetize that data. How is that new revenue streams for me? What can I do to not just, improve my bottom line, but also my top line out of that?
If I had £1 for every day someone said that to me, I wouldn't need to monetize the data. Sorry, it's just such a valueless concept, I'm afraid.
And on that financial note of advice from the piggy bank of Telco, there was so much more we wanted to talk about. We wanted to talk about digital twins. We want to talk about the role of Open RAN. We have run out of time. So hopefully we can continue our conversations next door because it's lunchtime now. We've got an hour for lunch, so I'm sure we can pick up on many of these themes. And we're back here in an hour's time for our second session with Ray. In the meantime, Please thank our guests very much indeed. Thank you.